Alright, for problem 2, for this one, my denominators are x plus 1, x minus 1. And again, these don't really have anything in common. It's two completely different expressions. So for the LCD, the best we can do is multiply them together again. Alright, so to get the first fraction to have that LCD, I have the x plus 1. I'm going to need the x minus 1, which means I have to do it also in the top. And then for the second fraction, I have the x minus 1. I'm going to need the x plus 1, and we'll also need to do it to the top. Alright, so 1 times x minus 1 is just x minus 1. One times x plus 1 is x plus 1. And now the fractions have the same denominator. So we can collect the two numerators over that common denominator, and then we just need to simplify. So I have x plus x is 2x. Negative 1 plus 1 is going to be 0. So we get just 2x in the top. And that is over my LCD, x plus 1, x minus 1. So that's going to be our final answer. Alright, for number 3, this time my denominators are not in their lowest terms. Both of them can be factored out. So we're going to need to do a little bit of work first. If I have x squared minus 3x minus 10, for the sake of time and space, I'm not going to write out all the steps for doing this. We have a trinomial with a equal to 1. So we know we have to have x in both of the first spots. My c is negative 10, and I'm trying to add to negative 3. So I'm going to need a negative 5 and a positive 2. Now, if you need to do that work, just go off to the side and make sure you can do that, because you will need to be able to factor these things. And for the second denominator, this is also a trinomial with an a equal to 1. So I need x times x. Then my c is negative 5, and I want to add to negative 4. So I'm going to need minus 5 and positive 1. So my denominators are x minus 5, x plus 2, and x minus 5, x plus 1. So for the LCD, remember I said we need one of each unique thing. So I need an x minus 5, and I need an x plus 2. When we get to the next one, we already have an x minus 5. So we don't need another one. And then I need an x plus 1. So if we write out our original, now we want to get the LCD. So for the first fraction, I have the x minus 5 and x plus 2. What I'm missing is the x plus 1. So we need to do that to the top and bottom. And for the second fraction, I have the x minus 5 and the x plus 1. What I'm missing is the x plus 2. So since I don't have 1's in the top this time, I'll have 5 times x plus 1 over that common denominator minus 3 times x plus 2 over the common denominator. Now the next thing is to collect the numerators, but I want you to notice this time that we have a subtraction, and we need to be a little more careful when we do. So when I write these numerators together, I'm going to put the minus and then put the second numerator, and it's all over this same denominator. We have to be more careful with subtraction because, of course, when I distribute a negative, then that's going to change the signs of everything behind that sign. So if I simplify this now, I'm going to get 5 times x is 5x, and 5 times 1 is 5, minus 3 times x, and that's minus 3 times 2 is minus 6, all over that common denominator. And then we just need to clean it up. 5x minus 3x is 2x, plus 5 minus 6 is minus 1, and that's over the common denominator. So that is going to be my answer in lowest terms. Alright, so if I look at number 4, we're going to have a similar issue. First, I'm going to need to factor out both of those denominators. So for this first one, it's a trinomial. A is equal to 1. I need to multiply to 25 and add to negative 10. So this is going to be a minus 5, a minus 5. And of course, that could also be written as a minus 5 squared. Then for the second denominator, that's a difference of squares. So I can write that as a minus 5, a plus 5. Alright, so my denominators are a minus 5, a minus 5, and a minus 5, a plus 5. So I'm going to write this one as a minus 5 squared because we need to see the difference between this problem and the last one. So in the last problem, my first denominator was x minus 5, x plus 2, and my second one was x minus 5, x plus 1. We only needed one of the x minus 5 terms in the LCD because we need at least one of each unique thing to the two different denominators. So the x minus 5 in those, one was in the first denominator and one was in the second. Over for this one, that first denominator actually has 2 of the a minus 5s. So one of the unique factors is a minus 5 squared. So in my LCD, I'm going to need an a minus 5 squared from here. Now when I get to the second denominator, that a minus 5, we don't need a third one because we already have 2. So we need a minus 5 squared and a plus 5. So for my original problem, in order to have the same denominator, for the first one I have the 2 a minus 5s. What I need is an a plus 5. And for the second one, I have 1 a minus 5 and an a plus 5. So I need a second a minus 5. Alright, so we're going to get 3 times a plus 5 over a minus 5, a minus 5, a plus 5 minus 2a times a minus 5 over that same denominator. So then if I multiply, well, let's write them together first. 3 times a plus 5 minus the 2a times a minus 5 over that common denominator. Alright, now let's simplify the top. So I have 3 times a, 3 times 5, minus 2a times a is minus 2a squared, and then minus 2a times minus 5 is plus 10a over that denominator again. Oops. Alright, so let's clean this up a little bit. So our squared term needs to be out front. So let's do negative 2a squared. Then I have a positive 3a and a positive 10a. So that's going to give me 13a. And then plus 15 over a minus 5, a minus 5, a plus 5. Now what we do have to be careful of is I have a trinomial in the top that is not in factored form. So we have to make sure if it is factored that nothing will reduce with that common denominator. So if we look, since I don't have a equal to 1, we would do a times c, and that gives me negative 30. And we're going to want to add to 13. If you start looking through the factors of negative 30, then you're going to find that what it factors into, I think I ended up with, I'm going to put this here and then you can check behind it if you want to. I factored out a negative 1 first. And then it turned out to be 2a minus 15 and a plus 1 if I factored that out. And neither of those factors is going to be common to the ones in the denominator. So that means we can leave the answer just like this. Alright, let's look at one more. So for this fifth one, the first fraction has a denominator that's in lowest terms. We just need to factor the second one. And it's a trinomial with a equal to 1. And if I want factors that multiply to 12 and add to negative 7, I think we're going to need minus 3 and minus 4. So this one's back to a simpler LCD, I think. So we need an x minus 4. And from the second one, we need an x minus 3. And we already have an x minus 4. Alright, so let's write out our original. So for the first fraction, we want x minus 4, x minus 3, and I only have the x minus 4. So we need the x minus 3. For the second fraction, I need x minus 4, x minus 3, and that's what I have. So we do not need to multiply that one by anything. So for the first one, we get x plus 1, x minus 3 over the common denominator. The second one stays the same. And then we can write them together. X plus 1, x minus 3, minus. Now, this one, you see how I have that x plus 1 there? You want to make sure you put a parenthesis in there, because we're going to subtract that whole thing. So what's a little more difficult about this one, of course, is we have a binomial times a binomial. So remember, we can use FOIL, you can distribute, or you can use the box. Whichever method you choose, we should get x times x is x squared, x times negative 3 is negative 3x, 1 times x is x, and 1 times negative 3 is minus 3. And then if I distribute that negative 1 times the x plus 1, we're going to get negative x minus 1. And that's over our common denominator. So if we clean that up, we have one squared term. Negative 3x and x is negative 2x. And another negative x is negative 3x. And then we have negative 3 minus 1 is negative 4. And now we're in the same situation as the last problem. We need to see if the numerator, if we factor it out, will give us anything we can cancel. And you can probably guess, since the last one didn't, that this one does. So for this one, at least it's a little simpler, right? I have a equal to 1, so we know this has to be x and x. I want my factors to multiply to negative 4 and add to 3. So we're going to need minus 4 plus 1. And that's over that common denominator. And you see this time I have a common factor of x minus 4 that I can cancel this time. So my final answer is x plus 1 over x minus 3. Don't worry, that's as bad as it gets. The last thing that we're going to look at is going back to that function notation that we've talked about before. So similar to when we're dealing with polynomials, sometimes when we deal with rational expressions, we're going to need to give them a name. So we're going to use this function notation again. So for a problem like this one that says, given f of x equals that expression, find f of 2. It's going to work like the polynomial did. The 2 is in the position of the x. So this is basically asking if x is equal to 2, what do I get? So I want to introduce a little bit of notation or terms here that we're going to start using in the next lesson. So remember, when we're using this function notation, that means that we're now referring to a rational function, not just an expression. So what's different about that is in a function, there is exactly one output for each input. We can also talk about things in terms of inputs and outputs, where your input is always going to be your x. You can think of it as, if it's an application, it's the independent variable. The output is going to be f of x, which remember is just another way to write y. And we call that one the dependent, because what you get depends on what x is, right? So what's happening visually is, if I give you a value for x, we're going to apply the rule f, and the rule f is this rational expression that we gave you, and see what we get out. So that's a lot of explanation just to try to start introducing some terms to say it works very similar to when we did polynomials. If I want f of 2, that means that I'm going to take my original rational expression, and everywhere there's an x, we're going to substitute a 2. So then we just need to simplify this. 2 minus 3 is negative 1. Then you can work that denominator out, or you can enter it into the calculator. I ended up with 7. Hopefully that came out correct. So to write this in function notation, that means for this particular rational function, if x is 2, the output that we get is negative 1/7.